head-mounted display create a highly immersive experience, however, which limit VR users' awareness of external users that co-located in the same physical environment. In our work, we conducted a hybrid user study to compare the wearable gesture-based interaction and the traditional controller-based interaction, to investigate the effects on VR immersion, social presence, and collaborative efficiency for external users. For the gesture-based interaction, the external user wears a Vive tracker that attached to his head to locate the relative position in the virtual scenario. An accompanying virtual camera projects the external user's perspective onto the physical environment. We use leap motion that tied around the external user's waist to interact with the VR user in real time. For the traditional controller-based interaction, the external user uses a Vive hand controller that attached a 7-inch removable screen as a virtual camera to display the scenario and perform the same tasks. We compared the wearable gesture-based interface and the controller-based interface for external users in two main asymmetric VR scenario: 1. Object transition and 2. Collaborative game. Selection and transition of virtual objects are important interactive behaviors in VR collaboration. In object transition scenario, both VR and external users should pick up specific color notes and throw them to each other. We provided object interaction by generating virtual rays in gesture-based interaction, which includes 3 hand gestures: click, summon, and pinch. The external user can select the blue note through a generated blue ray by pinching with 5 fingers. Then he or she can summon the note ball by flexing the 4 fingers, and placed into the square to throw at the VR user by pinching hand. The VR user can place the purple note into the square and pass it back to the external user as feedback. For the controller-based interaction, the external user can press the handle button to pick the blue notes into the box, and use the trigger button to teleport himself nearby the VR user. The collaborative game is a typical interactive form in asymmetric VR. Therefore, we designed an asymmetric cooperative game. There is a difference between using gesture-based interaction and controller-based interaction to send messages and controlling a searchlight. For the gesture-based interaction, the external user looks for the location of the puzzles and send gestures to inform the VR user where the puzzles are. VR user can teleport and pick up the puzzles in virtual scenario. The external user controls the range and brightness of the searchlight by pinching the index finger and thumb from the right hand, and send an OK gesture to inform the VR user that the puzzle has been found. VR users can confirm the message through the controller and teleport to pick up the puzzle. In the controller-based interaction, the external user can slide the slider to control the searchlight and click the UI buttons to send messages by using the controller. We conducted a primary study with 20 participants to study the VR immersion, social presence, and collaborative efficiency of the gesture-based interaction and the controller-based interaction. The results showed that the VR experience and social presence in gesture-based interaction reported significantly higher entertaining interaction experience in comparison with controller-based interaction. For collaborative efficiency, in collaborative game, the gesture-based interaction reported significantly higher scores in comparison with the controller-based interaction. External users use natural hand gestures to transmit information and cooperate more efficiently. Due to the learning cost and accuracy rate of gesture, there were no significant differences in object transition. In this paper, we conducted a hybrid user study in 2 scenarios by comparing the gesture-based interaction and the controller-based interaction in asymmetric VR. A primary study showed that our wearable gesture-based interface received more positive feedbacks on the sense of VR immersion, social presence, and collaborative efficiency. The external user had a stronger sense of immersion and social experience due to the freedom of hand gestures and body perception. Meanwhile, our system still needs to be further improved in terms of learning cost and gesture design accuracy. The participants also provided additional suggestions for future implementation: 1. Comparing gestures-based interaction and controller-based interaction in different collaborative scenarios; 2. Designing more natural and cognitive gesture-based interaction.